But it's actually going to be one of the hardest problems we ever do.
Can you tell us the name of it? So that we know if it's
It's called trig integral.
Oh no. You say trig or trick?
Trig integral. Trig substitution, actually, to be very precise. So obviously, you're going to see the problem right away. Can you tell me where is the problem occur? Use substitution, does it work?
No.
Why not?
The degree. I don't know.
Yes, you're right. Go and keep on. You have to have the confidence to finish it.
You saw like when you take the derivative of x squared, like x cancel out.
Right, there's nothing x, and there's no way to do back substitutions because there's no x there. Usually there's an x outside, right? Or 2x squared outside or something like that. There's something you can do either back substitution or not. So today we're going to learn how to do integration of something this sort of a squared plus x squared, or a squared minus x squared, or x squared minus a squared. Any type of situation, it's doable. Okay, it's doable. Does that make sense? Now, there's no way for me to take integral of this as of now. Why? Because
It is a squared plus x squared.
it is a squared plus x squared. Yes, you're right. But there's no way for me to do it now until we learn some new trick of doing things. What are the new tricks? Well, why do they call trig integrations? We cannot take integrate of this, so what we're gonna do is we're gonna use something gonna lead to have something like this. So when is the time that you have 1 plus x squared square root? Yes. Pythagorean theorem, very, very well. So I always draw a triangle. And I'm gonna have a data. I'm always gonna have the same orientation. I'm always gonna have same orientation. When are you always gonna get square root of 1 plus x squared? What do you think that side is going to be, the hypotenuse or the legs? Hypotenuse. Does that make sense?
Yeah.
Because usually it's square root of 3 squared plus 5 squared, and that's 3 squared plus 4 squared, that's equal to 5, right? So that's usually the hypotenuse. So we're gonna say, hey, this is the hypotenuse of 1 plus x squared. Usually when you see this situation, it's usually that is end up to be hypotenuse. If that's a hypotenuse, what will be the legs? 1 and x. But remember, you want to set your trig substitution with constant on the bottom. Constant has to be on the bottom. So which trig I'm thinking of that where is a constant up on the bottom? You have 3 choices. You have sin, you have a tan, and you have secant. Which choice that you're gonna have a constant on the bottom?
Yeah, it'd be tangent because
Well,
it depends. It depends what you put for
Oh yeah.
Yeah, it depends what blank you use for what value.
Okay, so now what we know is sine of theta is equal to opposite over hypotenuse, and tangent is opposite over adjacent, and the secant of theta is equal to hypotenuse over adjacent, right? Does that make sense? So those are the 2 things you need. So then you said, well, I want this x and 1. Why is x and 1? Because I don't want a 1 over x. Oh, I don't want the tangent of data is equal to 1 over x. I want x over 1. So therefore, I'm going to substitute this. I'm going to say tangent of data is equal to x over 1. We're using the triangle to do the integration now. We use
I love calculus.
Basil, stop sounding like a nerd, please. I don't even sound like a
I think
nerd.
I figured it out, and I'm like, it's cool.
Okay, well,
You know?
it's a little bit more than that. Shh, it's a little bit more than that, but this one is the hardest one. Okay, so if I were the integration of this, so I want to change this x. Well, we know x is equal to 10 of it, 10 of data, right? So it's going to be integration of square root of 1 plus 10 square of data. Does that make sense? But here's a slight problem. Can you tell me where the problem is?
What's theta? Unimportant.
We have a dx. We have a dx, but do we have a d data?
No.
No. So what do you have to do? You're going to take this tangent of data of equal to x. I'm going to take the differential of that, so which is going to be secant squared theta of d data equal to dx. You can integrate. I don't know who was saying that. Oh, Miss Num was saying that you cannot take an integral of something that two different variables. I think that's what you say, right? You have a d data, or you have a x, or you have a data, but you don't have, you have a dx. You want to make sure you convert the x to the dx, to the d data. So this process is super important. So this one is going to be integration square root of 1 plus 10 square theta. Now instead of replacing dx, I'm going to say that secant square theta d theta. I change everything in terms of data. And then you say, oh, okay, life's a lot easier, but it's not true. How can I simplify this? That becomes integration of secant squared theta, secant squared theta d theta, right? So that's going to be integration of secant cube theta d theta. And that becomes the... That's the... Thank you, Paige. It was the extra credit.
Oh, great.
Now, the extra credit that you've done, if you did it right, then you will get specific integral that's on your notes from integration by part. This is the one I said it cannot be done by integration with the integration by parts. It kind of like work halfway between cyclic and the halfway a little bit different. So, what'd you say? Well, yeah, we're... Okay, so now instead of asking you to take an integral, let's go back your notes because I know Ginger has the notes. What's the integration of a secant cube? Now, instead of doing that, you can look back your notes. Can you guys tell me what's the integration of secant cube?
plus natural log of secant x plus tangent x all over 2.
This one's 1/2, right?
Yeah.
1/2 natural log of secant of theta plus tan of theta plus c. The problem is, it looks like we're done, but it's not. Thank you. You have to change it back to x. Okay, so let's recopy this triangle. I'm lazy, so I'm gonna copy. I'm gonna paste here, and I use as a reference. So 1/2 secant is equal to what? Hypotenuse over what? Hypotenuse
Over adjacent.
adjacent, so it's, which is over 1. Does that make sense? And what's tangent theta? It's x over 1. Does that make sense? Plus 1/2 natural log of secant of theta. What is secant theta? Again, it's square root 1 plus x squared plus x plus c. And then you're done. And this is the finally done.
Okay, so tangent is x. Okay. Alright, that's not too bad. What is like plugging in our definition for what is work? But don't worry about that. Don't worry about that. Okay? Well, I'm trying to worry about the things I don't understand. Everything else, you know what?
All right, so the problem is there was 3 different kind. There is square root a squared plus a x squared. This is the easiest one. There is a square root of a squared minus x squared. There's a square root x squared minus a squared. How do you decide which one's which? Now you have to understand there's certain things. Yesterday I had to go back and restudy that and really analyze and break it down. Watch a video like 6 times to figure out how do I teach it properly. And for me, I started to realize that my calculus teacher in college in UF, they just told me memorize instead of understanding. So what I want you to do is actually understand instead of memorize, because memorize is not a key of doing math. So understand something. So what we're gonna do is we're gonna make sure that this one, the idea, so the ideas works for square root a squared plus x squared, which is we already know, which is deal with tan of x. Now how about square root a squared minus x squared is equal to secant square of theta? You already know this, the Pythagorean identity. Or 1 minus sine square of theta is equal to cosine square of theta. Or one other situation, I don't remember. But which is you can derive. We can go back and write it. So let's talk about the first situation. We already did the first situation. No, we didn't do the first situation, sorry. So square root of a squared minus x squared. In order to have this, you have to recognize, is this hypotenuse or the leg? Why do you think it's a leg, RJ? Very good. Your intuition is great. Your intuition is great. Well, we also, yeah. We also already used the hypotenuse, so which is good. Okay, so then you gotta think. You have a choice between psi. Problem is, how do I assign this triangle? Now, here's the thing. So if I say is this one is the psi, So which side would it be? The bottom or the right? Remember, we have to write down the triangle. And I always have to do this. So if you say this is the side, which side would it be? Are they going to be the vertical one or a horizontal line? Now, what's more important, actually, what is the hypotenuse? Why do you think the hypotenuse is that?
From A squared. No, it's A squared. Oh, because square roots, yeah, moving square roots is square roots.
First of all, let's figure out what is this side. Hypotenuse is A or X? X negative inside. So A has to be in the front because the A, it has to be hypotenuse. If A is shorter than X, then you're going to have a square root of a negative number. Does that make sense? So that's a very important to understand. To figure out this is A. Okay, let me rephrase that. How many of you guys don't understand? Just go ahead and raise your hand if you don't understand what I say. Okay, Jake, that's good. Jackie, that's good. Good. I appreciate that you guys are brave enough to say it. Guys, I cannot talk over you. This is the first time I'm teaching. I don't know how many of you guys don't get it. You have to tell me the truth. That's it. This is 3. This is... That implies if A is important. Now, we have a choice between which 3 choices that we have, right? In relationship,